All right, let's get started. Today, we'll discuss the Kubernetes concepts for DevOps engineers. Michael, welcome to the show.
Thank you guys so much for having me. Appreciate it.
I know, right? This is the second time you've been on. I mean, the last time we had you on, it's probably one of our most watched videos as well, Mr.
Nice.
Levan. So I'm always a fan of your tweets. Quite controversial sometimes, but I think it's quite appropriate. Well, it is, right? Playing devil's advocate works, right? So it's like self-validation sometimes, right? To get people to comment on stuff, right? But yeah, I'm quite a big fan of it. But yeah, got Michael on today to talk about his book, right? I've learned a lot from it. It's gave me a good I say it's gave me a good grounding. It's brought more clarity to the situation because literally, I would say about 5 weeks ago, the penny dropped at last, right? It took me a while, right, to sort of, because it was such a mess, right? Because people sort of obviously talk about Kubernetes, right? And it's so wide reaching, right? And actually, it's about the platform that runs containers, right? And how we containerize our applications, right? So what was the purpose of it? So yeah. But yeah, Mike, we know you obviously, but do you just want to give yourself a quick overview and a quick introduction, right?
Sure. Yeah, no, and thank you guys so much for having me on. Really do appreciate it. Of course, appreciate you guys reading the book. Hopefully it was, informative, and that was kind of the goal, right? So yeah, my name is Michael Levan. Thank you so much for that. I do everything and anything Kubernetes and containerization. Now, when I say everything and anything, I mean I'm consulting. So I'm still hands-on. I'm still in production level environments. I'm still writing production level code. I'm still creating all of the things. I also create a lot of content, whether it be stuff like this, blogs, videos, public speaking, books, yada, yada. And then the third thing I do is a lot of live training. So organizations will bring me in and say, hey, our team needs to get, trained on GitOps for production environments and all that stuff. And really the whole goal with my content, and this is how I try to separate myself, is I don't just create content to create content. I don't just push stuff out and push it out. My content is specifically around real world production level scenarios. And I'm able to showcase that in my content because, again, I am still real world and I am still spinning up Kubernetes environments, in production.
No, I completely relate to that because at the end of the day, I think sometimes folks forget why we build services, right? And it's to be consumed, right, by our internal or external customers. That's just the way it works. So
That's why. Okay.
well, it's right. Well, it is right. I mean, we do a lot of home lab stuff, right, or learning, or the innovation. But that's something I took away from this book. It was like, well, I want to run this in production because I have a mission critical workload, right? And how does that work? But I just wanted to start off from the beginning, right? Because I think this is really big, and this is the point that you sort of talked about as well in the book, was the shift to the cloud, like where we've come from, right? From 2009 or 2008, I forgot when AWS kicked it off, right? But and how we shifted to the cloud native approach. So the mindset of coming from on-premise to the cloud, people just started moving servers or running, PaaS services, right? As we started rolling up to 2016 or 2017. But now we've got, this cloud native approach and how that affects our architecture. So I think it's really important that we start there because I see it time and time again. I speak with customers every day. They try to take what they did on-prem to the cloud, and then it doesn't really work after a couple of years, right? And they back themselves into a corner and all that good stuff. But then we're introducing all this, to them is like the Starship Enterprise, right? Like this cloud native stuff. But actually, I think you tweeted, I think it was last week, Kubernetes has basically gone generally available, right? It's like production ready. It was not bleeding edge anymore because people are using it, right? In anger. So do you want to just talk about that a little bit?
Yeah, absolutely. So I'll touch on both of those things. The one thing that you said around Kubernetes being GA, yeah, at this point, I believe that it is production ready. And what I mean by that is it's not just this hot new thing that people are labbing up. For example, if we think about WASM right now, there's a lot of stuff around WASM. There's a lot of stuff that's being built around WASM. In my opinion, WASM is not running in every production environment. It's not there yet. However, it takes time, and I'm sure it will be at some point. Kubernetes is now that thing. It is that thing that it is running in production. Big organizations are actually using it to orchestrate workloads. It's no longer the hot new sexy thing. It is the thing that you're using in production. Very much like how ESXi came out. There were a ton of people that were like, this is going to be for labs only. This is never going to be production ready. This is a toy. And then at some point it reached this level of, professionalism, or whatever you like to call it. It reached this level where it was like, okay, we are now using this thing in production. And I believe the past year or so, this is now where Kubernetes is right now. And then to your point around cloud native, yeah, I don't believe in like the lift and shift model. I'm the first person to always say, like, I don't want to use buzzwords and I don't want to, think about it from that perspective. Lift and shift doesn't work. There's two parts of this. There is what is happening in the underlying and where you're moving it. So the underlying piece, storage is storage, memory is memory, networks are networks, IP addresses are IP addresses, firewall rules are firewall rules. That stuff doesn't change. But what changes is how you're running it and ultimately where you're running it. To give you a great example, Kubernetes is Kubernetes, right? The project is the project. It's out on GitHub. You can see the code. You can build it. You can deploy it yourself, etc. However, where you're running it is vastly different. I can give you a Cilium config right now that's ready to replace kubeproxy, that's ready to remove IP tables and use eBPF instead. I can give you this Helm chart that does it in EKS. And if you try to run that same Helm chart in AKS, guess what? It's not going to work. You can't just lift and shift things in the cloud, because the way that you run it is going to be vastly different depending on where you're going. And that's just the Kubernetes scenario. That's not the scenario around serverless. That's not the scenario around PaaS. That's not the scenario around OpenShift, or wherever you're running, it's always going to be drastically different. So my long-winded answer to your question is the underlying stuff is always going to be the same. Networks are networks, IPs are IPs, firewalls are firewalls, et cetera, et cetera. Where you're running it is going to depend on how you're going to run it, regardless of if the platform is the same or not.
That's pretty awesome. It's like when I'm speaking with customers and they go, we're having a digital transformation, right? There's another buzzword for you. You love that, right? And they go, we're going to migrate our service to the cloud. And I'm like, well, it's not a digital transformation, right? It's a migration.
Right.
Right?
Yeah. You're never gonna transform to the cloud, or you're never gonna migrate to the cloud. I believe that you need to go into it with a net new approach. And when I say net new, and I think this is where the confusion kind of comes in, because people say, I want to do a cloud transformation, or I want to migrate to the cloud. Yeah, I'm not saying like you have to take your entire application stack and like rewrite it in another language. That's not what transformation means. You can take that same code, you can take the same dependencies, et cetera, and run it in one place or another. But you can't just take what you're running in bare metal and transition it into Azure, AWS, or GCP or wherever. Like, it just simply doesn't work that way. It's a different technology, right? Like, it's like taking an apple seed and expecting to grow an orange. It doesn't work.
Interesting
analogy. Yeah, I like that.
That's where a lot of people, end up not being happy with the cloud. Right now, I'm being political correct. One more buzzword, and we have buzzword bingo, by the way. So let's see who goes home with the refrigerator. But and then they just lift and shift the workloads, don't optimize them. It's heavy stuff, Kev.
Yeah. I've just spilt water all over my screen, but just
man.
Oh,
All right.
shit.
Last time
swear.
that I moved, I had a 49-inch screen, and I was moving it, and I laid it down in my truck, and I plugged it in, and the entire screen was broken. So that was a good $3,000 that I just threw away. So I get it. Hopefully that doesn't happen to you too, just now with the water.
Uh-oh. All right. Yeah, shall we?
Sorry, Robin.
No worries. That's the beauty of life, right? So, no, what I was trying to say is that a lot of people migrate their workloads, like just lift and shift, right? It can be a good first step, but a lot of organizations then decide, like, oh, well, it's running there. We exited the data center. Well, let's focus on something else that delivers business value, right? So, if you then transform it or modernize it is the term, then you're in a much better place, cost effectiveness, and other, scalability, elasticity, and all the other buzzwords, ilities. These are not buzzwords, these are ilities. But anyway, long story short, lift and shift is not the way to go. Right. So Kubernetes is one of the runtimes that is optimized for the cloud, or at least abstract away the underlying infrastructure.
Yeah, I would totally say so. I think it's one of many ways. I don't think Kubernetes is the only way that you can do this. You can run serverless, you can run OpenShift. Yes, I'll differentiate between OpenShift and Kubernetes, even though it's the same thing underneath the hood. But there are different ways. There are various ways to deploy. You don't need to use Kubernetes. However, it also comes down to who's building for what. Like for example, if you think about Docker Swarm is arguably far easier than Kubernetes, and it's also arguably doing the same exact thing. The problem is that everybody stopped building for Swarm and started building for Kubernetes because that was the hot new sexy thing that people cared about. And for the engineers out there that have never went through the process, behind the scenes, if you want to build something, you need money. And if you need money, unless you're bootstrapping it yourself, you need VC backing, venture capitalist backing. So you almost are forced to go with what's hot and new and sexy, or else you're not going to have the money to build what you want to build. So I can guarantee there were a ton of people that wanted to build for Swarm, for example, but everything was going towards Kubernetes. And because everything was going towards Kubernetes, then you're now it's almost like a monopoly, right? Because if these vendors aren't building for X and Y, they're only building for Z, you kind of got to go with Z at some point. And I believe it's the same thing that kind of happened with VMware. This is just what everybody was building for. And because of that, you kind of had to go in that direction. And I'm a firm believer of that's why we're kind of moving towards Kubernetes right now, more or less. Is Kubernetes the best option out there? I'll be the first person to tell you that it's not. Is Kubernetes what everybody is going towards and what everybody's building for, and therefore you should ultimately be implementing it? Yeah.
Makes sense. It is, I've been to KubeCon last week, really interesting. Lots of sessions, and at one point they presented 159 projects that are currently under the CNCF flag, basically, or in the CNCF ecosystem, if you will. And there are even projects who don't make it to the sandbox, right? So there are much more projects out there, all adding, or most of them adding functionality to Kubernetes to make it do things that it was not originally designed for, or to really solve certain challenges, right? So that's what happened. So the whole discussion is not around Kubernetes, Nomad, Mesos, Swarm, or whatsoever. That's settled. It's now revolving around all the other projects that are built on top of, next to, or whatever related to Kubernetes.
Exactly.
Yeah. And I never really looked at it from a monopoly perspective, but it's like this continuous thing. Okay, we just built for one thing, so that thing is the only thing. So, anyway. So, do you want to share a screen? Do you want to get into some of the concepts, or?
Absolutely. Yeah, let's do it. So let me make sure that I share the proper thing here.
Yeah. So we won't question what was on screen.
Give me one sec. Let me just confirm. Yep, that looks good. Okay.
All right.
Let me make sure. I just want to make sure that is sharing properly.
I see it. Let me know when I can. You want me to add it?
Yeah, no, if this looks good to you, because I can't see it on my end, just wanted to make sure. Oh, yeah, there we go. Now I can see it. Beautiful. Good. Okay. So when I am working with clients, This is also going to be in a self-published, well, maybe self-published, have to see, probably, book that I'll be writing within the next couple months. And then also I have a course coming out around Kubernetes real world stuff. It's on pre-sale right now. Everything that I do around my courses, around the book that I'm going to be doing, and especially client work, this is how I break everything down. This is my my secret sauce. I'm giving it away to everybody for free. This is how I map out how I'm gonna have my clients look, okay, in terms of their environment. So I break it down into day 0, which is the planning phase, day 1, which is the implementation, and then day 2, which is the management. Okay. Now, I'm happy to dive into any of these if you'd like. Some have more information than others, simply because we cannot stay on this live stream for 3 to 6 months, which is typically how long I see this being implemented. So I couldn't put all of the information in here, but again, a lot more of the information will be in my course coming out. So, and I break it down for the things that are, maybe not the sexy thing, right? So like, for example, in day 0, two of my biggest things before I start any work at all is, do I have the proper point of contact and do I have proper access? So like, yeah, I could write all the Terraform code in the world and spin this thing up and do all the GitOpsy stuff and yada, yada, yada. But if I don't know who I'm supposed to be talking to, and if I don't have access to that AWS or that Azure or that GCP environment, guess what? I'm not going to be going very far, right? And then we go into the architecture phase, and then we think about the planning out the security protocols, right? So this is funny, something came up a week or two ago on social media around the security stuff, and I kind of had to go a little bit deeper into it. So I plan my security stuff in day 0, and then I implement it in day 2. All right.
Awesome.
So for example, if I go into this, right, it could look something like this. It could look like network segregation. It could look like ensuring that I have proper namespaces. It could make sure that I have proper RBAC, that I'm using cluster scanning, etc. And then in day 2, then I'll actually start to implement it, right? So I'll start to talk about, okay, these are the tools that I'm using, these are the practices that I'm taking, and then again, the different tools or whatever is available. Give me 1 sec. Apologies,
So
I have an awful cough.
Day 0, day 1, and day 2. Can you repeat that one more time? What is day 0?
Yep. So day 0 is the planning phase and the making sure you have all your ducks in a row phase. The day 1 phase is, okay, we're going to start implementing this thing. We're going to start deploying stuff. And then day 2 is, okay, we're going to start managing it and having our third-party tools and our add-ons available. So like, for example, I'm not going to put service mesh in day 1. Why? Because in day 1, I need to actually deploy my applications. I can't use a service mesh if I don't have anything deployed. So that's why I put it in day 2. So day 2 is primarily around, testing, upgrades, scaling, management, etc. But it's also where some of those third-party tools and add-ons will ultimately be implemented.
All right. So you first lay the foundation, you build a house, and then you start adding, stuff in your garden and other. I'm trying to come up with a better analogy, but then you start adding other stuff to your home, like
Exactly.
Curtains and other floorings and other stuff.
Yeah, and that's what Kubernetes is, right? Kubernetes is, I don't know if you guys have ever seen this or if anybody on the live stream has ever seen this, but when a house goes up, like you go through, like when you're building a house or when you're building any commercial building, whatever the case may be, you first go through the architecture and the planning phase, right? How this thing is going to look. Then you start implementing it. So once you walk into that house, it has the roof and it has maybe some doors and windows, etc. But when you walk into it, it's bare. You got a room here where you think your bathroom's going to go. You got a room over here where you think your master bedroom's going to go. But you ultimately have to piece all that out and see what it's going to look like. So day 0 is the architecture phase of the house. I'm just building. I'm just thinking about how this thing is going to look, let alone developing it. Then the day 1 phase is, okay, I have these slots all over the place. I can put a bathroom here. I can put a master bedroom here. In a Kubernetes analogy is, I have this open area. I can put a little CNI over here, a little CSI over here, a little GitOps over here. And then day 2 of the Home is, okay, my house is up and running. All right, maybe I want to pop in a pool over here. Maybe I want to change the bathtub out. Maybe I want to, change some different tiling and some ceiling lights and all that stuff. From a Kubernetes perspective, that's the, okay, my Kubernetes cluster is built, my applications are deployed, etc. Now I need to think about, okay, how is this thing going to scale? Okay, what testing tools do I want to use? Okay, do I want to do monitoring and observability and backups and disaster recovery? And then how am I going to implement my security stuff? Because in my opinion, these are all prerequisites of each other. So like I can't deploy a cluster unless I have a plan. I can't deploy security protocols unless I have something to secure. So these are all like step 1, step 2, step 3. You can't kind of go out of bounds with each of them. I mean, you can in certain instances, but I don't recommend it.
I think, tech folks anyway get caught up with the implementation phase.
Right.
And we've all been there.
Right.
Every one of us, right? Like we just want to see, in this instance, the cluster up and running, right? Like,
of course,
that's like an achievement, but like you said, it's more like, do I have a landing zone? Do I have the services that are available? That kind of thing, right? Like the proper point of contact, that's golden, right? Because how many times has that happened? You've written all the manifest files, but you don't know if it's going to actually deploy all right, because there may be certain constraints on the environment, right? Or you may have to upskill the customer, or whatever, right? So,
and a lot of the time when I get called in, it's exactly because of what you just mentioned, which is why in the day 0 phase, I also have the refactor phase. So a lot of the time when I get called in because, hey, we deployed this thing and it's not working as expected. And a lot of the times I got to go in and I got to rip everything out, start from scratch. Sometimes I don't, sometimes I do. But going back to what you said, Kevin, that's exactly what happens. And I'll be a little controversial. I don't believe that it's the engineer's fault. I believe that it's leadership's fault and management's fault. And the reason why is because a lot of the time, engineers do want to do things the right way, but then politics get involved, right? Something deadline, something, because this person said so, something, blah, blah, blah. So all of this stuff gets implemented super fast and super quick. And then 6 months down the road, you're like, I just built this house sideways. We can't really live like this unless we want to be laying like this, our entire lives, right? So now you got to flip the house back over. And when you don't do the day 0 piece properly, that's, what we're all familiar with, tech debt. You have a massive amount of tech debt that ends up occurring. And again, I don't believe that it's not 9 times out of 10 in from what I've seen, right? From full-time jobs, from consulting, from working for myself, it's usually not the engineers that are implementing it. It's because they don't have the time to get it done properly. So that's what I see more or less. And then the other side of it is you don't know what you don't know, right?
Yeah, for sure.
So you can implement something and think that it's the proper way, and then you bring in a consultant to check to see if it was the proper way, and then myself or whoever has to be like, nah, we got to rip this thing out if you want it to be successful later on. So it's a combination of you don't know what you don't know, and slow down, get it done right the first time.
I think that's what you mentioned in your book as well, right? Start slow, go fast, right?
Oh,
it's the terminology you use, right? So
just had a question here. I wanted to knock that one in, but you just blew it. No, that's exactly what you mentioned in the book, right? Starting slow, going fast. So I need to plan first, make sure you have a foundation in place to prevent technical debt, get your ducks in a row, and then you can go faster and faster as long as, along the way, things are getting clearer.
Yep.
So now to have I'm on the mic anyway. There's a question from Jeff, which is a really valid question. Let me throw it on screen. Mm-hmm. And now it covers Michael's face. That's really weird.
That's okay. Do you find providing the tool set you will implement beneficial, or do you find allowing the group you are consulting to make a decision?
Followed by this one.
Yeah. So for example, choice on service mesh. So I think it depends on the overall scenario. You want to plan what tools you're going to use up front. You don't want to have to think about this later on, you know? So if you're comfortable with Argo over Flux, if you're comfortable with Cilium over Calico, if you're comfortable with Pulumi over Terraform, whatever you're comfortable with is the okay approach, but you should definitely think about what you're going to do prior and ensure that all of the teams also have an understanding of what's happening. So I'll give you an example. Let's say your developers are going to be the ones that are building and maintaining Kubernetes, and they're very comfortable with Python. Well, it's probably better to give them something like Pulumi versus give them something like Terraform and say, go learn this. So it's all going to depend on the scenario overall.
Yeah, love that answer. I visited the booth that. Oh, okay. Stop sharing the screen. But there were two.
Sorry, did I?
Yeah.
No let me pull that back up. Apologies.
And I do hear an echo.
Well. Yeah.
Hello.
Hey,
Yeah.
you still hear the echo?
Yeah.
Really?
Hello. Yeah.
Let me see. Hold on.
Hello. No echo.
Yeah, weird.
It's you.
It's me? Give me 1 sec. How is it now? Any better?
Hello. Yeah, better.
Better? That was
Yeah.
weird. StreamYard just changed my mic to my webcam.
Well, luckily we figured it out. Right? We cannot do this over, or we cannot cut this out because hey, it's the beauty of live streaming. Oh well,
There you go.
Keeps me out of my perfectionism, so that's good. So no, what I was trying to say, or what I was trying to explain, was that at KubeCon I went to the maintainers area where they had like the Flux and the Argo, just literally like one stand, and at one side where the Argo, on the other side was Flux. And I'm comfortable with Flux, and I was like, oh, what does Argo do that Flux doesn't do? Well, it's a little bit of a different approach, but they do the same, right?
Mm-hmm.
They do it in a little bit of a different way underneath the hood, but eventually the end result is the same.
Right.
Developers have a tendency to lean towards Argo because it has a GUI and somehow, yeah, they like to be able to see their deployments and their statuses and stuff like that. While Flux doesn't have that out of the box, you can still add it. But what the Argo maintainer, one of the core maintainers, told me, he said, if you're happy with Flux, then coming from an Argo CD maintainer, don't change. If you're comfortable with this, keep on using this, and that ties perfectly into what you just said. Like, if you're already using this, then keep on using that, right? If you use Python, keep on using Python. If you're comfortable with a certain service mesh that suits your needs, and you're happy with the results, then just stick with that one.
Yeah, and I think that kind of brings up a good point of just thinking about the CNCF landscape overall. There's so many tools that do the same thing, which is fine, but you don't have to feel like you have to pick one or the other. You like whatever you're comfortable with is totally fine.
Yeah, good point.
Apologies, I have such an awful cough right now, so I keep muting myself.
No worries. All right, one more question before we move on. What is the best way to transition to Kubernetes?
Oof. Yeah, how much time do we have? So I believe having a very strong infrastructure background is super important. I believe having a good understanding of how storage and servers and scalability and networking works. I would argue that that's 80% of Kubernetes. Then the other 20% understand application delivery. You don't have to be a principal developer creating the next Twitter or Instagram or whatever. You just have to understand how to deliver applications. So I would say if you got those things down, you're pretty good for the transition.
Chris, can you elaborate a little bit more on delivering applications?
Sure.
So
Absolutely.
what does that entail?
Yeah. So I would say how an application works underneath the hood. So again, like you don't have to write the code, but you should understand things like applications have dependencies. Applications need to be containerized with X, Y, and Z. Applications need a continuous delivery or a continuous deployment method. Application code is stored in GitHub, and therefore, let's say you're using Argo or Flux or whatever, you have to authenticate to GitHub. So you have to understand the idea of application delivery, of how to get from point A to point B versus writing the code yourself. I would say you still should understand how to write code, but again, you don't have to be like principal developer for the past 20 years.
All right, makes sense.
I think touched on something there, because that was the bit that I was trying to get my head around, was again the buzzwords, right?
Again. Echo.
Yeah. Is that better? If I be quieter, can you still hear me?
Yeah, I hear you. I don't hear echo anymore. But...
No. So is why we're running these containers in the first place, right? And it's the host applications, right? So I wanted to get my head around how do you containerize an app? Yeah, because I like to know all the details, right? That's just the way my mind works. What's the whole point of doing this in the first place, right? Kind of thing, right? Because we think back traditionally, and I think you mentioned it in your book as well. Again, Michael, was we used to build a server, right? Or we'd virtualize a server, and then we'd install the application stack, blah, 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 blah. It's like, how do you containerize it, right? Like, what's the minimum tool set that you need to containerize an application, right? Like you said, you don't have to be a developer, but obviously you need all those dependencies and runtimes in there to make that application work, right? So when you understand the app a little bit better, you can then plan the configuration of the architecture, right, of where you're going to land it, right, for its use, right?
Yeah, you need to definitely have that combination there. It's not something, you can't just understand development and jump into Kubernetes. You can't just understand infrastructure and jump into Kubernetes. You need to have a good understanding of both sides of the house. And, funny enough, when DevOps kind of went from this philosophy to being like a job title, that was kind of the gist as well, right? The gist was you need to understand infrastructure and you also need to understand development. So this is something that we've seen across titles, across jobs, across application stacks for a very long time at this point. And it's an ongoing trend. This trend isn't going away. If you look at any platform that's running right now, it has both the application delivery side and the infrastructure side. So it's certainly a trend that is not going away, in my opinion.
Awesome. I know we've got some questions there, but I just wanted to touch on the whole, the delivery side of it. So like you mentioned, we had DevOps, right? Yeah. And that's the approach, right? I want to make that crystal clear, right? Before I start getting the Twitter bandwagon crew after me, right? But how does that work in regards to, now we're talking about platform engineering, right? Because we had infrastructure engineers, right? We had network engineers, security engineers, blah, blah, blah. But now we have platform engineers, right? And the joke is that platform engineers have to out-engineer themselves out of a job, right? To create reliability. But how does that work with, when we're talking about maybe DevOps tools? And then you mentioned GitOps before, right? So how does that work? That's like the next stage, right? It's like that release cycle of the infrastructure and application. What are you seeing out in the field, right? Or your experiences around that?
Yeah, so I'm a little bit biased because, the whole idea of platform engineering is to build internal developer platforms. It's to give a developer some code, some buttons, something, and say, click this, run this, boom, now your environment's up and running. It's essentially to make a developer's job easier. I mean, I don't know. I've been doing that for the past, since DevOps was a title. I don't know. So like for me, it's like I'm very biased because I've been doing that as with sysadmin job titles. I was doing that. So, I think it's kind of less about the job title and more about the functionality of what you're doing. But then at the same time, you also kind of do want to follow the job titles simply because, as we all know, when there's a hot new job title, you're getting a lot more money for it. The job role could be the same between a sysadmin job title and a platform engineer job title, same exact role, but you're going to get a lot more money if you got that platform engineer title. So that's really the only time that that titles come into play there with that. Yeah, and sorry, was there a second part to your question, or was that
it was around about the whole, I'd say, GitOps phenomenon. Right?
Yeah,
like the I wonder if you could just talk about that a little bit more.
Sure. Yeah. So let's peel back the onion there in terms of what GitOps is. So GitOps is a few things. Number one, GitOps is continuous delivery, right? You click a button or you run a thing and poof, your code is there. And then every single time you change code in source control, it then gets deployed, right? So that's one part of it. The other part of it is GitOps is configuration management, because what is configuration management? Same thing as continuous delivery, right? You have these check-ins and you have these intervals, and let's say every 15 minutes it looks and it deploys the new thing. That was the whole idea of configuration management. So peeling back the onion, really, GitOps is just giving you the same thing as we've had for X amount of years now. The key difference is it's doing it for Kubernetes. My camera is about to die. I'm going to switch to my other webcam really quick. Give me 1 sec.
I have a little bit of a messy stream today, but
I love these ones though. I'll be honest.
Yeah.
I know it's probably driving your OCD crazy, but
no. It's I'm
all right.
I'm actually growing in
go.
that sense. There he is. It's not that sharp, but we'll deal with it.
Soft lens, right?
There you go. Yeah, it's the like the Logitech something. I don't know, one of the webcams.
Sweet.
Right. Okay.
So, but GitOps pull versus push versus pull, basically, right? Storing your configuration in Git. It's immutable. It's declarative. It's being reconciled. So every 15 minutes, 10 minutes, whatever you configure, an agent in your cluster goes out to the repository and ensures that the state of the cluster represents the repository, right? And that's basically functionality that Kubernetes gives you already. The schedulers, the reconciliation loop, being extended out to your configuration or your desired state, if you will, that lives in a Git repository. Exactly. Right? We can talk about mono repo, poly repo, blah, blah repo, buzzword bingo repo. But, it's, I do think that it's good that it's being, there's also an open GitOps initiative now that basically defines the characteristics of what GitOps means. And it's not necessarily technology specific. Right, so these are the characteristics that defines GitOps, but it's not necessarily this tool is GitOps, or the same with DevOps, for example. Like Azure DevOps is DevOps. No, it's not. Right, it's a tool to enable you to well, let's not go there, but it's a set of principles and practices, and not necessarily technology. The technology enables you to live up to these expectations or these promises, basically.
Yeah, and I think that's, if I could give any piece of advice to everybody on this live stream right now, it is peel back the onion. Remove the technical marketing jargon, remove the what's hot and what's sexy and all that, right? Peel back the onion. So going to your point, Robin, what is GitOps? It's the same thing as what the scheduler is doing and this and that. Yeah, you have controllers in Kubernetes and you have the deployment control and the replica set controller and blah, blah, blah. And what is the job of the controllers? The job of the controllers is to confirm that your current state is your desired state. If your current state is not your desired state, fix. That's the whole idea. If you're supposed to have 2 replicas and you only have 1 replica, that replica set controller is going to ensure that it does everything in its power to get that second replica out. It's the same thing as GitOps. That's why it's called a GitOps controller, because the idea of it is to confirm that your current state in your Kubernetes cluster is your desired state, what's in your source control. So when you think about it like that, the gears start, everything clicks, right? Because GitOps isn't giving us anything new and fancy. It's just giving us a certain method of performing an action when we're talking about application delivery. So I oftentimes, and this is for better or for worse, I feel like I have to come in and pop everybody's bubble and be like, peel back the onion. Because a lot of the times engineers right now, because of all the different tools, because of all the different methodologies of deploying, everybody's confused, right? Nobody knows which direction to go in because there's so many buzzwords and there's this and there's that and blah, blah, blah. And that's why I say, peel back the onion. Think about what's happening. Look at it from an engineering perspective, right? Like put your engineering hat on. Take the technical marketing jargon out, take this out, take that out, and look at the platform and the tool for what it is. Once you do that, things are going to start to click and you're going to be like, oh, this isn't as confusing as I thought it was. Like I promise you, and that's what I do, right? Like that's my job. Because I focus on Kubernetes, my job is literally to make Kubernetes easier to utilize in production. And that combines the third party and the add-on tools like Service Mesh, like GitOps, all of that stuff. My job is to peel back the onion for you and make it all make sense. So again, if I can give one piece of advice to everybody, it is peel back the onion, look at what's happening underneath the hood. Because I'm telling you, we're doing things today that we've been doing for the past decade. We are not doing anything different. The only difference is how we're getting application A to its destination. We're getting there in a different way, but the underlying stuff is all the same.
But that ties into cloud as well, right? We're just, CPU, memory, right? Or compute storage networking, basically.
Yeah, exactly.
Right? So it's not different than what we did before virtualization. Then we added virtualization on top of that, so a layer of abstraction. And then now we're abstracting that even further away by not virtualizing the OS, but virtualizing the app, or at least a mini OS, because it's not just the app. That would be WebAssembly. But this is like the app with just this library, it's buying, dependencies, if you will, to run inside a virtualized container.
Exactly. Yep.
Right?
And it's the same thing as, like, for example, VMSS, right? Virtual machine scale sets in Azure. If you look at the documentation, it's very lengthy, right? But when you peel back the onion, what is it? You have X amount of servers, some are available, some are not until you need them. What is that? Hot, cold. We've been doing hot, cold scenarios in infrastructure for 20 years. You would have servers that are on, you would have servers that are on standby. When the load pops up, those servers come into play and now they're active. So again, like that's just, like you said, Robin, even in the cloud, like we're seeing this, we're seeing if you just pull back the onion, it's going to make everybody's lives so much easier.
Yeah, for a conceptual understanding, definitely,
Right,
of course.
right.
And then you have the institute keys, or whatever, how to pronounce it. I'm living above my pay grade again from a word perspective, but of course, you have the technology specific characteristics, right? Different way to put it, but it all starts by wrapping your head around the concept that you're looking at, and then build out from that starting point. At least that works for me. I always try to simplify things. Like, okay, exactly what you just said. What are we doing here, right? Oh, wait a minute. We're just doing this, but we build up. We layered it with another layer of I cannot talk today. Jesus, we layered another layer of abstraction on top of it, right? Hence, like what Azure did, data centers. Well, ARM on top of it, Portal, some APIs that you can talk to, some tooling around that, and now you can consume compute resources that you're not responsible for from an infrastructure perspective, right? Data center, storage, cooling, all the other things.
Exactly.
So let's circle back to the book, right? It's full of tips. It's like 50 concepts, right? So, and it's full of tips, things that you need to consider. So, and this is going to be a hard one, or maybe you just, pull it out of your sleeve. But what are your top 3 tips for running Kubernetes in production?
Good question. So I would say the first thing is understand where you think your load is going to go. And what I mean by that is do not architect your Kubernetes cluster solution where you're going to be running a small workload right now, but in 6 months, you're going to be running a much larger workload. Ensure that you're building for what you think you're going to be running later. Now, you're never going to know like exactly what 2 years is going to look like from now or what 10 years is going to look like from now. You can't do that. But what you can do is, okay, I have this application running and right now there are 3 customers on it. However, I do believe that in 6 months, based on projections from leadership's teams and blah, 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 that we're going to have 30 customers. Great. Build for that 30 customers. Make sure that you have cluster auto scaling on. If you're in AWS, make sure that you're utilizing something like Carpenter for just-in-time nodes. If you're in Azure, maybe you're using something like VMSS or ACI bursting, whatever the case may be, wherever you're running, ensure that you're building for later on. And the second thing is make sure that you understand how you need to build for the cloud that you're in. Again, going back to what I was saying with Cilium before, I can give you the same exact Helm configuration for Cilium that worked in EKS, won't work in AKS. That goes into, for example, overlay. You mentioned overlay. I forget if you mentioned it before the call or not, but overlay in EKS is a nightmare. Whereas in another cloud, it may not be. So you want to make sure that you understand what you're deploying and why you're deploying it, but how you need to run it in the cloud that you're in. Okay. And then the third thing, understand the difference between enterprise tooling and homegrown solutions. Now, this is just my definition. I don't think that this is a definition outside of my own brain. I tend to just make stuff up and talk to myself, and there's just a lot of conversation happening in here. Enterprise, let's think about monitoring and observability. Great example. Enterprise would be, you're going to go Datadog. Datadog has everything monitoring. It has everything tracing, metrics, logging, APM, etc. If you go homegrown, you're going to go with something like Prometheus, Grafana, Jaeger, logs.io, a few others probably for APM. Understand what solution you're going to be going with throughout all of your tooling. And the biggest thing to understand and remember is if you go the homegrown solution, because of course a lot of organizations, especially startups, want to go the homegrown solution because it's free. However, it is not free because you still have to pay engineers to manage it, and you may have to hire more engineers later on to manage those workloads. So if you're going to either go the enterprise route or the homegrown route, ensure that you understand what that load is on your team or on your finances.
I like that. So it's like, yeah, like you said, homegrown may be free, but then you can't outsource that. You can't, depending on how your organization's set up, right? Can you look after this environment in 6 months? Because it could start small and then it's production, right? And someone's got to monitor it 24/7 and have the skill sets. And exactly. I see that as a big gap generally most of the time, right? Is like the skills readiness, right, of a team. Like there's always one person who's got an interest, right, in the new technology, right, on every team on average, right?
Yeah.
And they're leading the way, but actually the rest of the team, if that person's off or whatever, right, or like you said, they scale to the point it's just going to put, you can have a single point of failure, right, with that one person, right? So how do you plan for that, right?
Right.
Kind of thing. So
yeah, and this is a big thing that teams end up having to go through because they implement all these tools because it's open source and it should only take 5 minutes, and we all know how those conversations go. 10 months later, you're not done with the project yet. You really got to think about what this thing is going to look like later on. Otherwise, you're going to have a ton of tech debt. And to be honest, a lot of employee turnover. I forgot the word for a second. A lot of employee turnover is due to the fact that, hey, we have all this stuff. We don't have enough people to manage it. Now I need to work 7 days a week, 12 hours a day. So there's a lot that can, there's a trickle effect when you don't focus on day zero first.
Awesome.
It's, and I would like to add one thing, and I've been searching for that for a long time. It's like the perfect solution, right? The perfect architecture, the one that's like the golden path, will solve all my problems. And that one doesn't exist, right? So it's perfectly fine to start with something that's not good enough, but evolves over time, right? Of course, I'm not saying skip day zero. You do have to plan and think about. At one point, you have to start building, and take this in a certain direction, right? And it's perfectly fine if that one isn't perfect, but ends up being as good as it can be, right? So it's always about managing trade-offs, like which one is the least painful, which one is closest to what I need, right? But this goes into architecture a little bit more, but trying to build something that suits all use cases is setting yourself up for failure, right? Because something like that doesn't really exist. And if you're trying to build that, then it's going to be a monstrosity of a solution, because you're adding a lot of bells and whistles that you may need in the future. Right? And if you add all the right components, well, not all, but you start with basic things like autoscaling, right? Understanding the cloud that you're building on. I've been working with AKS for a while now, and I've been figuring out new stuff over the weekend that I didn't know yet, because there's so much to understand. And that's perfectly fine as well. So it's interest, have an appetite for learning new things. But it's also allowing yourself to sometimes fail and build up that experience. Right? And then, of course, deal with that accordingly. Right? Okay, we failed. Okay, we need to address this. Sometimes it's painful, but I think that's part of the process. Right? And we're trying to innovate here. Of course, we're still doing the same things that we did underneath the hood, but we're trying to, reach new levels of what's needed nowadays. Right?
Totally.
Planet level scale and all that other stuff. I'll shut up. Your turn.
No. And you're 100% right, and that's exactly why, like in my day zero, day one, and day two piece that we were sharing earlier, all of those bullet points or those pages can be the same across my clients, but how I implement each one will not be the same. So the skeleton is the same, but the internals are not. And to your point, if I try to make the internals perfect for every single, it's impossible. Like I can't make those internal, like I can't just have a blueprint that I give to every client. It's never going to work that way. I can, however, have a plan in my head of like, this is what should be in phase 1, phase 2, phase 3, and then maybe some other things like we should always go with Cilium because X, Y, and Z, like stuff like that. But ultimately how it's going to look and how you plan it out and everything, it's always going to be different for each environment. I've never, ever walked into an environment when I was a full-time employee or when I was consulting. Well, I still am consulting, but when I was a full-time employee and when I was doing my own thing, I never walked into an environment where it was like the same across the board. It doesn't work that way. And I've been working with Kubernetes since 2016, 2017. So.
Awesome. So I'm just conscious of time. I wanted to touch on something that Michael talked about earlier, right? Because I like to get hands-on, right, with everything. There's code snippets in the book, which is really great. You've published a repo, right, of manifest files and all that kind of good stuff, right? Because I think that's a lot of it. People are like, where do I start, kind of thing. But you mentioned you've got a course coming out soon, right? So it's like an instructor-led course. Do you just want to talk about a little bit about that, right? Because sometimes it's great watching someone else do it, if that makes sense, right? To try and like you said, when it all clicks, right? So do you just want to mention that maybe?
Absolutely, yeah. So I have a course coming out. It's on Gumroad right now for pre-sale, $29.99 USD. It's called Kubernetes Real World, and the whole course is going to break down day 0, day 1, and day 2. We're going to be doing like an actual implementation that's following a storyline throughout the whole course. So I'm sorry, one sec. Apologies. So it's not going to be where it's like, here's what a pod is and here's what a deployment is. It's going to be like, okay, you already know that stuff. Let's now figure out how to get this stuff into production. So it's going to be literally like a story. Like we're going to be, watching a movie the whole way through.
There's a scenario, right? There's yeah. I mean, sometimes that's the best way, right? To learn, because like you sit there and you go, what should I build this around, right? What's going to give me the most exposure, right? And that kind of thing. So
yeah, because I see a lot of like content and a lot of courses and stuff out there that do a really great job at explaining what X is and why you want to use X. But I've never personally seen a course out there that's like, here's how you can implement this thing in production. Here's the scenario. Here's the storyline. I haven't seen that yet at all. And that's why I'm creating it. Because I think that that's an incredibly crucial piece. And that's kind of where I live, right? Like I'm not teaching people how to use Kubernetes. I'm not teaching people what Kubernetes is. They already know that information by the time they get to me. I'm teaching them, here's how to use it in production. Here's how to use it in a real world scenario. That's my bag.
It's called Kubernetes and Containers, the real world, right? Learn what you need to succeed as your job. There were some people interested in the link in the chat, so I posted it there.
Yep. Yeah.
You got a really interesting Gumroad page, man. So
thanks. Yeah. Yep. That is it. Yep. Yeah. And as you can see on there, it will be released June. So a couple months, but pre-sales, if you want to jump in on it now, and this price, of course, will be going up after pre-sales.
Sweet.
So like a early bird access, right?
Exactly.
Get in there now, right?
Exactly. Yep.
Invest in yourself.
Exactly. That's it. Yeah. And something else that I haven't said publicly yet, but I'll say it now. Surprise. And I think I kind of mentioned it earlier, but I'm going to be creating a book on this as well. That's going to be following the course. Yeah. Thank you.
Keep it coming, man. That's all I can say, right? Like I enjoy them thoroughly, so keep them coming.
It's like a low level of BS, cut to the chase.
Yeah, I like that.
Writing, right? So it's. By the way, this unfortunately we can never discuss this whole book in 1 hour. We have a tendency to sometimes, discuss topics that are not directly related to this book, but I think nevertheless it was really valuable. But yeah, I always feel like it's already 1 hour. We're already 1 hour in.
Yeah.
We discussed a lot of different topics. I think we discussed a lot of interesting stuff, like try to understand what's going on underneath the hood, peel back the onion. I don't know. I have a couple of more minutes, Mike. I don't know about you.
I'm open.
Yeah. Do we want to discuss one final thing before we wrap it up today?
Sure. What do you have in mind?
Yeah, that's a good one. That's a really good one. I haven't really thought about it yet. I was like, hey, I don't want to stop this conversation. Kev, anything that crosses your mind?
Something. Yeah.
Okay.
Totally. Right. I don't think we can fit it in 2 minutes though. Security.
Oh, yeah.
Because well, the RSA conference is happening this week.
Mm-hmm.
So for folks that aren't in the security game, right? RSA conference is a massive security conference. It's happening out in San Francisco. And what I've learned is that, I mean, shame on these people, to be quite honest, but there's some clusters out there with public endpoints that aren't protected, right? And are now being compromised and used for crypto mining currencies, right? And that kind of thing. So they're actually going in there and replacing. So all the stuff that we talked about, right? They've weaponized it, right? And they're pushing out images to run basically crypto mining workloads on there. But from a security point of view, now I know every cloud platform's different, right? Every CSP is different, have different policies and ingress and egress and all that kind of good stuff.
Mm-hmm.
But is there any like let's just say top 2 tips, right, around security that you would look at, right, from inside the cluster, right? Be that the images, be that, the deployments, etc. Have you got anything, that you could advise?
So I don't have 2 specific tips, But I could throw out 2, but like once I throw out 2, I need to throw out the other 50.
Yes.
So what I would say is, number 1, begin to understand the CIS benchmarks for Kubernetes. It is a report that is over 200 pages. There's a lot that goes into it. You don't have to read all the 200 pages or memorize it all. You could use a tool. One tool that I really love is Kubescape by Armo. Great tool for scanning both clusters, pods, Kubernetes manifests, all that stuff. So you want to make sure that you have a proper scanner in place. The next thing is, Kevin, to your point, and this goes back to the architecture, you want to make sure that you know what you're deploying. I don't know if anybody here has ever gone to the Shodan website, SHODAN, but it's essentially a website that just kind of scrapes all public endpoints. And you would not believe how many public Active Directory servers are out in the wild. Craziness. Same thing goes for a Kubernetes cluster. So if your control plane is sitting publicly, and by the way, that's default if you're deploying via cloud provider. Don't ask me why. It shouldn't be the default, but it is. You want to ensure that you set that up in another fashion. So you want to make sure that you have public subnets and private subnets. So again, this is a very long topic, but the long and short of it is, you want to make sure that your control plane is sitting on the private subnets, and you want to make sure that you have public subnets available for things like your Kubernetes services that customers need to hit externally. You want to make sure that you have, again, I'm going to say it again, your clusters are on the private subnets, and your Kubernetes services that need to sit publicly, for maybe they're a front-end app or whatever, they can sit on the public subnets. Because when you're creating Kubernetes clusters, you can have both private and public subnets. You want to make sure that you have both. And that'll solve the problem, Kevin, of what you're saying.
Interesting. What about my AKS cluster that has Azure AD authentication and role-based access control enabled and local accounts disabled? So I have this public endpoint, which is completely locked down. I need an AD account. I have MFA enabled. That account needs role-based access control, or that account needs roles with underlying permissions that are available within my cluster. Would you still go for like a private cluster?
I would, yeah, because I think that what we've learned over the past 20 plus years of cybersecurity is that there's always going to be one permission that's misconfigured. So there's always going to be something out there that's misconfigured. And to be honest with you, that is the biggest cybersecurity issue, in my opinion, especially when it comes to Kubernetes, is misconfigurations. I don't care how good you are, you're going to have one misconfiguration somewhere, and you're going to find it and you're going to fix it. But by the time you fix it, it may be too late. So you want to ensure that you have all of your eggs in the proper basket when it comes to that stuff. And Azure AD is great. I actually, even for my customers that are not in Azure, I always recommend going Azure AD. I believe, Active Directory has been the de facto standard for authentication and authorization for a very long time, and for very good reason. It is incredibly good at what it does. However, you could have, the best stuff in the world, but you never know. Like, once something's public, you never know. So I always say, err on the side of caution.
It's a little bit like, I can always have remembered this pen tester who came in, and it was back when we still had switches and stuff, and he plugged in his laptop to do some pen testing, and he didn't get an IP address because there was a MAC filter on the port, right? He's like, well, can you give me an IP? Well, no, right? You're trying to hack into the system, right? Yeah, but I need to run pen tests. So what I'm trying to say is that if you're not able to connect to something, you can also not hack into it.
Sure.
Right.
Yeah.
So if your endpoint is not public and it's a private endpoint, then you really have that covered. Of course, if they get into your private network, other discussion, right? But at least you're layering your defense, right?
Exactly. Totally. Yeah. And that's the whole idea of cybersecurity. Cybersecurity, you can never stop everything from happening. It's utterly impossible. the whole goal, and this is outside of Kubernetes, this is just general cybersecurity, is to mitigate as many risks as possible. That's it. You're never going to be able to stop everything, but you want to follow the best practices to mitigate as much as you possibly can. And because that typically doesn't happen, because it takes a long time, that's why we have security issues.
Defense in depth. Right?
Defense in depth. That's it. Yeah, if there's anything good you can take away from computer science, everybody that's listening, defense in depth, amongst other things, of course. But
Great.
Awesome.
Yeah, man.
Right.
We can go on like this for hours. Actually,
I know.
So,
Okay.
usually that's
All
a
right.
good thing.
It is a good thing. It is a good thing. So, Michael, where can people find you online, right? I know Twitter, right? Like hit them up on Twitter. Where else?
Twitter, yeah. I still haven't done anything with Blue Sky yet. I'm still kind of waiting to see if that
It's
goes
like
anywhere.
Mastodon, right?
So here's the thing about me. Like, I don't have personal social media. Like, the only social media that I have is for work. So I'm very off social media in general for no other reason other than I believe that it's a very large distraction. But I have work social media because I like to connect with people and I like to teach and yada yada. So right now, the best places to find me, LinkedIn. I'm far more active on LinkedIn nowadays than I am on Twitter. But Twitter, I'm still posting, and if you send me a message, I'll still see it and all that good stuff. So those are the two best places that you can find me. And on my Twitter, you're going to see a link. It's going to be a Linktree link. And if you click on that, it's going to show you all my stuff.
Awesome.
Yeah.
Awesome. Okay. All right. Let's wrap this
Nice.
up.
Let's do it.
You got anything else to add, Robin, before we let him go? Because like he's turned up like a trooper, right? He's coughing, he's had camera issues, everything, right? He's done an amazing job. So yeah. Just want to say thanks again. It's always a pleasure having you on, right?
Absolutely.
And just keep doing what you're doing, man.
Absolutely. Thank you so much, guys. I really appreciate it.
Okay.
Absolutely. Thanks, Mike. Thanks
you.
everyone for joining. Yeah, don't be a stranger. See you later. Bye.
See you later. Bye.